Hi everyone. Today we are going to discuss limiting an excess reagent. So first, what we need to understand is a proper definition of what we mean by limiting reagent. So limiting reagent is part of the reactants that is completely used up during a reaction. And excess is something that is completely the opposite. So it's not completely used up. So we can better understand this by, let's say this is a cake. It's a birthday cake. And we need ingredient A and ingredient B to make this beautiful birthday cake. Okay? Now, let's say we have used all of A. It's finished. All used up. So it's all consumed. But B, on the other hand, it's not fully consumed, okay? Let's say we had 1,000 grams. We used it all. And this one also we had 1,000 grams. But yeah, we have maybe, let's say, 50 grams still left. So this is our excess. So anything that is left over is known as the excess reagent. So this is a pretty simple way to understand it. Now let's try to understand it from equation, in terms of equation. So let's say we have A plus B that makes up C. Okay. Now, when we look into this, we have to understand what exactly is it saying. What this is saying is that we need one of A and one of B to make C. So A, we need, when we have one A, we need one B. Or when we have one B, we need one A to make this product called C. Now, let's change things a bit. Let's say we have two here. Change the color. So let's say we have two here now. Now, what does this mean? When we have one A, we will need two of B. Or when we have two of B, it's the same as here, we would need half of that. So half of 2B is going to be A, and that's going to make C. Now, what about when things changes a bit? Let's say now we have something two A plus 3B. Let me just put a line here. This makes C again. And now how can it be? Yeah, like now what's going to be different here? So we can say to make 1C, we need 2A of 3B. So we need 3 of 2 into B. This is pretty basic maths, okay? Now let's try to put some grams here, okay? Let's play with some weight. Okay, let's say this is 10 grams, okay? So if I start with 10 grams of A, how much of B would we need? It's pretty easy. We would need 20 grams. When we start, let's say, okay, this is over, okay? Now we start with 20 grams of B. How many grams of A do we need here? No, this is going to be 10 grams because it's going to be half of it. Similarly, okay? Now, let's say, let's start with some number, let's say 20, okay? Let's start with 20 grams. We have this, okay? And we don't know how much B do we need, but we know that based on the ratio, as we need here, if we have one of A, we would need double of that for B. Now, based on that ratio, we can calculate 3 over 2 into 20. So this is this. So we would need 30 grams of B. Is that clear? So this is how we actually use these equations, A and 2B, and how much do we need. But how do we exactly know what is our limiting reagent and what is exactly our excess reagent? Now we are going to look into that. Now, to understand that, it's best to actually think in terms of moles than weight, okay? But for the simplicity, we are going to just use gram, okay? A plus B equals to C, all right? So let's say this is 2B. Now let me change colors so it's a bit easier. Okay. Now let's say we start with, okay, leave what it's above, okay? But let's just say we have 10 grams of A and we have 20 grams of B. Now as we see, this and this, they are both correct, right? We needed 10 grams of A and we also need 20 grams of B, so it's already given. But now let's imagine a different scenario. 15 grams of B. Now, what do you think? Which one is limiting reagent? As I've said, limiting reagent is something that is less than required. Now we know we need 20 grams, but look how much we have, 15 grams. So this becomes my limiting reagent. And anything that is limiting reagent, besides that, it's all excess. Excess reagent, all right? So we can also now think in terms of moles, because that's more important since we are going to be dealing mostly with moles, or in terms of moles. So we can say, let's just give some random number. We have 4 moles. This is all moles. We have 4 moles of A and 10 moles of B. Okay, so now based on just our intuition, if we have 4 moles of A, how many B do we need? We need 8 moles. Now, let's see. Compared to this, we need 8 moles, but we have 10, so we have 2 moles extra. So anything that is extra is my excess reagent. So extra, okay? And when we have already calculated, okay, this is excess, this must be my limiting reagent. It's also important to remember that we can only have one, I repeat, one limiting reagent. And the rest, even if we have, let's say, now we have only 2 reactants, we could have equations where we have another more. Maybe it's, let's say this is F. So we have 3 reactants now. 3 reactants. And we have 1 product. So in 3 reactants, we must have 1 limiting reagent and 2 excess reagent. If we have 4, still going to be the same, and my limiting reagent then becomes 3. Now we have a complicated equation here. Now it becomes very complicated. Like, okay, so I have to find the ratio for this. From the ratio, there must be a simple way. And yeah, there is. There is a formula that you can remember. It is moles divided by the coefficient. Okay, and what is this coefficient? It's this number before a reactant. Okay, now how do we find which one is our limiting reactant or my excess reagent? The way to find is, okay, so now here, now we don't have any moles given here, so let's just put some moles here. Let's say 10 for this one. Let's say 30. This one, let's say 16. Okay. So this is my moles. Now, using the formula, 10, 5, I get 2. I get 10. 4. Now, among these 3 numbers, so we have, put the number here, 2, 10, 4. Which one is the smallest? This. This becomes my limiting reagent. And the rest, it becomes my excess reagent. Now, it doesn't matter. It could be even like, I don't know, nth number of something. But if you use this formula, you can always find which one is our limiting reagent. Now, let's try to understand this using proper equation. As we can see, now when we see this, what do we understand? We understand that 2 moles of carbon dioxide requires 1 mole of oxygen to make 2 moles of carbon dioxide. Now, so we know that, okay, if we have, for example, okay, if we have like 5 moles of this, we would need half of that, okay? Now, let's just put some random equations now, okay? So in an ideal world, if we have 5 moles of this, we would need half of that to produce the same moles of carbon dioxide, okay? Now, let's try using some moles now, okay? Well, we will put just some random numbers, actually, to actually have a good understanding. So using the formula that I've given you before, so again, remember, moles divided by the stoichiometric coefficient. So using that, we have 10, 2, 5. Since there's nothing, that's 1. So this becomes 5 and 5. So here, yeah, there's really no limiting reactant. So this is not really realistic. So I think let's change this number to, let's say, 12. Now this becomes 6, okay? Now which one is my limiting reagent? Well, that's pretty easy. It's this one, because this is the small number. All right, do we have it clear? Now we are talking about moles, but other times when proper questions comes up, what's given is mass. So that's X, that's Y. And now, then we have to find out the moles from the mass. And if you remember, the equation for moles is moles equals to the weight given and the molecular weight. What's important to note here is this molecular weight, because sometimes you might be confused. Okay, molecular weight, do we take into account of this thing? Nope, you don't. So the molecular weight, this one, is going to be just the molecular weight of this oxygen molecule. For this one, it's just going to be the carbon monoxide. For this one, it's just going to be for carbon dioxide. So don't ever include this in the calculation. So it's just going to be C and O2. There is no 2. You don't put that because sometimes people may make that mistake. Now let's solve one more problem when we talk about the product. Okay, find the product in terms of moles. Now let's play with some numbers for 2. And yeah, this is not given, right? Because you have to find the product in terms of moles. So this is the moles that's given. Okay. Now we are not talking about limiting or excess or anything like that. What we are talking about is how much of the my product moles is formed. So if we have 4 moles of this, okay, 4 moles of carbon monoxide is used, and we know we get the same moles of number of carbon dioxide. So this, the answer is 4. We can also think in terms of oxygen. So whatever we have, we must have the double of that product. So if we have 2 moles of oxygen reacting with carbon monoxide, we would get the double of that, which is going to be 4 moles. Now, you may be wondering, why is knowing the limiting reagent so important? Well, it's because it actually determines the amount of product that has been formed based on the limiting reagent. So first you have to find out which one is my limiting reagent, okay? Now, for example, here we have this. Let's say when we have this kind of equation, we kind of assume that, okay, it has been 100% used. The limiting reactant has been 100% used. So first, let's find out which one is the limiting reactant, okay? So we have 4 divided by 2, and then this one, we have, my moles is given 2, and this one, okay, this is the perfect one, but let's put something else, okay? Let's say this is 10, this is, let's say 4, okay? Now, let's find out the same way to find out my limiting reactant. So my limiting reactant, to find out this, we are going to use the, we're going to use the same way to find the limiting reactant. So this is 10 divided by the coefficient, which is 2. This gives me 5. And this one is 4 divided by, there's no coefficient, it's just 1. So we have 5 and 4. So this one is my limiting reactant. Now, when we say it's 100% consumed, we actually mean, this is what we mean, okay? 5, 4, and the amount of moles that was given to us was 10 and 4, right? So what we mean is that this is fully consumed, right? Fully consumed, 4 minus 4. I don't have any more moles left because that is my limiting reagent. Now what happens to the carbon monoxide? Okay, now this is where it's quite interesting. So when we have 4 moles of oxygen, how much carbon dioxide should we have or should we use? It's going to be 8, right? Because it's the double of that. And we have 2. So 2 moles of excess CO. Now what happens? What about my product? All right. So my product is going to be, now we know that if we have minus 4, we must have double of that. So if here is my minus 4, this initially there's nothing. It's going to be plus because we are getting the product. It's going to be 4. Oh, I'm sorry. It's going to be the double of that. So it's going to be 8. So 8 moles. 8 moles of CO2. All this while, we have assumed that 100% of my limiting reagent is used, but that's not always the case. Let's say this is 50% used. What happens? What does that mean? So initially, we know we have 10 moles of carbon monoxide and 4 moles of oxygen. Now we know this is my limiting reagent, and now this information is given. It's 50% used, so it's not going to be 100%. So, and let's say this is used, okay? So if this was 100%, we would subtract 4 here. Okay, let me just show you. We'd subtract 4 here. And what are we going to use here? Well, we know we have double of that. So it's going to be 8 if it was 100% used. But we know that's not the case. What we are given is it's used 50%. So what does that mean? It means it has been used 2 moles. Yeah. It has been used for the carbon monoxide. It's going to be the double of that. And what does that mean? That means if we have 2 moles for oxygen, for carbon monoxide, we are going to have double of that, which is 4. Now, what do we have here? We have 6 moles of excess and 2 moles of excess oxygen. So that's what it means, that it's not fully used. And that also determines my product, okay? So if I have 2 moles of oxygen, that is being used up to make 2 moles of carbon monoxide. So we know from based on the equation, we should have double of whatever is being used. So this is being used, and to get, since we're using 2 moles of oxygen, we are going to get double of that. And what is the double of that? It's 4 moles. So my product is 4 moles. Now, how is it different when we use 100%? Okay, let's do it again. 10, 4, and used. Now, this is going to be 4 because the 100% is being used, and 4 of double, this is going to be 8. So this is 0 because 100%, and this one, we still have 2 moles. 2 moles of excess. 2 moles. What about the product? The product is going to be 8. So, as you can see, 50%. Better understanding of limiting reactants and excess reactants. First, we see what information are we given. We are given the weight of nitrogen here, and we are also given the weight for the hydrogen. Now, the first thing, as I said, we have to do every calculation in terms of moles. So first, we need to find the moles. Let's aim here, okay? So this is for nitrogen. This is for hydrogen, okay? So let's find the moles first, as we are given here. 28. This is, as you may remember, it's molecular weight over, it's weight over the molecular weight. Okay, this gives me the moles. Okay, so we see the weight given is 28, and the molecular weight, nitrogen, as it's given here, it's 14, so it becomes 28. So this is 1 mole. What about hydrogen? Hydrogen, we are given 16 gram. And as we know, the molecular weight for hydrogen molecule, it's going to be 2. This gives me 8. Now, we have to find the limiting reactant. Always remember, this is a very crucial step. How do I find that? If you remember the equation, it's going to be moles over the coefficient. Let's see for this one. For nitrogen, the mole is 1 and the coefficient is 1. So this is just 1. What about this? Moles is 8, the coefficient is 3. Now, which one do you think is going to be my limiting reactant? Well, if I divide 8 divided by 3, we see this becomes 2.67. And this is 1. Which one is smaller? Of course, this one. So this is my limiting reactant. Okay, now that we have that, let's remove this. So moles should stay. 8 moles, 1 moles. Let's just highlight this. Okay. Now, when we see this equation, okay, 1 mole of this produces 2 moles of this, right? So, how many moles has been used? 1. And how many moles will produce? 2. So, the NH3 we will get is 2 moles. Now, how do we find the weight? It is simply moles into molecular weight. The moles is this, and the molecular weight, it's 14 plus 3, so it's 17. This gives me 34 grams. Now, let's imagine, okay? Let's just imagine, okay? For the sake of better understanding, we chose this one to be the limited reactants. Now, what difference does it make? Because if you remember, the definition of finding the limited reactants is to actually know the amount of product that has been produced or formed. So let's say this is my limiting reactant, okay? So 3 moles of this produces 2 moles of this, right? So the ratio is simply going to be 2 by 3, right? So let's say 8 moles, 8 into 2 by 3. This gives me 5.33 moles of NH3. Now, if we find the weight, it comes out to be 90.4 grams. Now, you can quite understand the big difference. 90.4 and 34. This is almost 3 times. So this is why it's quite important to actually know which one is your limiting reactant. Now, one quite important thing to note down when you do this is to actually see, is it fully completed? This word, this is a key word, till completion. If it says 80%, if it says 50%, then whatever moles you got for the limited reactant, you have to subtract that. So, for example, if it was A, okay, if it's still completion, that means it's going to remain A. But if it's not, then you have a new amount of moles used. So if it says half of it, it's 4. And it goes the same for all these. So now, let's say, we see that this one, when we have this, we produce double of that. Now, if that was not the case, it means we produce half of that, which means we would just produce 1 of this, 1 mole. And what does that mean? Produce 34 grams, right? This time, it's just going to be 17 grams. Solve one more question. Okay, we have hydrogen, we have chlorine, it produces hydrochloric acid. It also says till completion. So first, it's finding the moles. I have H2, I have CO2. Okay, so let's draw lines. easier. Now, how do we find moles? Okay, 0.6 divided by the molecular weight. This gives me 0.3. For this one, the weight given is 7.1 gram, and the molecular weight is 71. So this becomes 0.1 or 1 over 10. Okay, now let's call it finding the limiting reactants. As you see, both of them have the same coefficient. So even if you try to do it 0.3 divided by 1, 0.3, 0.1 divided by 1, 0.1. So now it's clear. This is my limiting reactant. Okay, good. Now, this is my limiting reactant. We see that 1 mole of this is going to produce double of hydrochloric acid. So if 0.1 till completion, so 0.1 fully used. So to produce HCl, it's going to be the double of that. So 0.1 into 2. This gives me 0.2. Now to find the weight, it's going to be 0.2, this is my moles. I would write it down, moles into the molecular weight. I should have written it the other way, but this becomes, raise this, molecular weight is 35.1 into 35.1 plus, so this becomes 35.1 plus 1, 36.1. So you can do the calculation. Got the gist of it.